Welcome everyone. In this video tutorial, I will teach you how to use transistor as a switch. Let's start. Uh, to use transistor as a switch, we need three components. One is NPN or PNP transistor, two resistors, and a control switch, a control signal. Either it is from a microcontroller or it is from any other device. As you don't know about microcontroller, so I will use a digital simulator primitive, which is in library of Proteus to perform this section. Let's start. First of all, we need I assume that you know how to use Proteus and how to pick components from library of Proteus. Write in keywords NPN transistor or the name of transistor, write NPN. If you don't know the name of any transistor, you can also write NPN. Now in category, click on transistor and select any of transistor, or you can click on generic to get a generic device which is capable of handling of any current and voltage rating. I have already told you what is generic device in Proteus. Generic device which is provided in Proteus to handle any kind of voltage and current rating. For example, if a specific device is not available, if a specific transistor is not available in Proteus, then you can use NPN transistor in this instead of this transistor, because it can handle any kind of power rating, current rating, and voltage rating. Double click on it, it will appear in your components list. Now we need a simulator. Write in keyword place logic simulator. Now click on simulator primitives and double click on generator digital logic bit generator primitive. Double click on it and click OK. First of all, to use transistor as switch, place transistor a resistor on the base. Assume that you know what is transistor. Transistor is three terminal device. This is base, this is emitter, this is collector. We usually take output from collector. While using transistor as a switch, we take output from collector, input signal at base, and emitter terminal is usually ground, connect with ground. To take a ground from terminal mode and connect it with ground, and now take another resistor and connect it with collector. Now for example, we want to turn on a LED. I'm just giving you an example. Write on keywords LED and now click on optoelectronics and select any LED. For example, I have selected LED green active LED. Double click on it, it will appear in your components list. Now connect it on collector. Okay. I have already told you, in while using transistor as a switch, usually we take output from collector. If you don't, I assume that you know how to use LED. If you don't know, LED have two terminals. One is anode, another is cathode. Usually we can connect cathode with ground and anode with a power supply. Now we want to connect a power source with the with R2 resistor. Now to connect power source, go to terminal mode and select power and connected with R2. Now to set voltages, double click on it and you can, whatever you write on string place, it will be the voltage. Let's suppose we write plus 12 volt. Okay, now we want to control this LED with the help of digital control. For example, at this input of R1, when input signal come from microcontroller, its LED become on. When no signal come from microcontroller, this LED remains off. So at this point, instead of using microcontroller, I have chosen mm, bit generator. No, this is not a bit generator. Let's check it again. Basically, you have to go to simulator primitives and find here exactly. Actually, I forgot the name of that device. uh, Doctors. So actually it is a logic probe. Go to components library and write logic probe. Logic probe. And now it will appear in you can select a logic probe from there, and after selecting a logic probe, click OK. I've already selected. This is the logic probe. Now connect it with the R1 resistor. Now turn on now we start the simulation. As you can see, when this signal is 0 and when input is 0, LED is on. When signal is on, LED is off. This is why this is happening, why we are getting inverting input, inverting output. This is because when logic high input is given to R1, actually it becomes short circuit. This transistor operate, this base to emitter junctions become forward bias, and this collector to emitter terminal becomes short circuit, and this and a ground will appear across LED. Now both sides are at the ground potential level. That's why it is turned off. When we turn when input signal is 0, now base to emitter junction is reverse bias, and it is becomes it become reverse bias, and it is open. Now voltage appear at 12 volt. After some voltage drop at across R2, voltage at point at after R2 appear cross D1, and cathode terminal at ground place. So current will flow this way, this way, and this way, and this way to the ground, and that's why LED is glowing. So this is how you can use transistor as a switch. Thanks for watching this video. I will come back with another example in next tutorial. Allah Hafiz.